Hello everyone. In this video, we will learn some rules and tricks to extract information from the labels of accounting trees. Well, the first thing I want to recall is that, first of all, when we say a path, specifically in this video, we mean a path from a point to the root. Okay? And label of the path, it means the label of the last branch on the path. So the path is a path from a point to the root. You always consider these ones, and a label of the path, a given path, is then label on the last branch. Now, based on what we have learned before, is that n of A intersect B, so on, this is equal to the label of the path, which includes both A and B. Well, this is the rule that we talked about before, but now I want to make it a little bit more general, because there might be more than one path which has this property. Okay, we will see an example at the end that this will happen. So we always, if there are more than one path with that property, we sum the labels. Okay. And now we want to see what will happen for n of union if there are union. Well, you do exactly the same thing. You add labels of all the paths which include both A, this time since this is union, or B. So it might be more than one. There are 10 of them. And we are not looking at having both A and B in it. It's either A or B, or maybe both of them. Okay, so this is the key point here. For union, you use or. For intersection, you use and. Well, as a result of these ones, if you have a set and you want to find n of B, if it is in the first level, that will be a label on the branch. If not, again, you do sum of the labels of all the paths which include, well, just B. Okay, so these are basically the key point for us. Any set given, we translate it into and or ors, and then find all the paths which has either those properties, and then add the numbers there. Well, let me show you one at least what I said here based on what we had on a very basic tree. So we already know that, for example, this one would be NA, this is NU, this is NA complement, this is N of intersection, so A intersect B, there's only one here, this is A intersect B complement, N of A complement intersect B, and N of A complement intersect B complement. Okay. Now, if you're looking for NA, well, you can go and find it from the labels. This only happens for the first level set. Okay, A and A complement, you can just find it. But what about we are looking for N of B? as the rule I wrote up there, which is a special case of both of the above. So this means that you go find all the paths which includes B. So here I have 1. This doesn't have this, the third one has, okay? And if you look at the numbers, the labels, and you write down the labels, the first one has NA intersect B, plus the second one has A complement B. This was actually one of the formulas we had, yes? So you partition your set B using another set and its complement, okay? So that was, but when it comes to the trees, it's just right away. You just find all the path which includes B and add them. How about N of A union B? So in this case, you go and find all the paths which include either A or B or both of them. So A or B. Okay, so here I'll go, this one has both of them. This one has A, see? And this one has B. So you add all these three, and that is enough union. And if I write it down, you won't notice any specific formula there that you want, but basically this comes from one of the combining 2 or 3 formulas that we have for numbers. But just know, if you have the trees, you don't need to be worried about the formulas. You just go ahead, find all the branches which include the sets based on the and or that you see, and then add all those numbers. Okay, let's see this in practice. So here I have a complete tree, and we are looking for NA. While I go and see, oh, NA, I can just come here and notice right away that A is not in the first row. And I see that it's in the second row. So I will find all the paths which includes A. And for that, I will just only use the second level passes. Okay, so this one is the one. Oh, there is another one as well. So NA is not like NF. NF is just here. It isn't one number. But NA is now separated into 2 pieces. So here, let me just write it down. NA is equal to sum of labels of 2 paths which include A. So in this case, basically sum of, well, I will labels of these guys. Okay, I'll try to be consistent with that. So the first one gives me 20, the second one gives me 10. Together, this is 30. That's nice. That's the number we were looking for. How about NB? B is in the 3rd level, so we have to go with that. So I have 1B here. There's another path. There's another path. There are 4 paths. So remember, for this, I have to find sum of the labels of all 4 paths ending to B. So in this case, we are trying to find sum of all boxes or squares or whatever it is there. And here I have 4 numbers, 10, 15, 8, and what, 44? Let's add these numbers. Am I right? Yes, so this is 25, 33, and then 77. That will go there. How about N of F and B? You would say, okay, just go find it on the tree, but you notice that F is in the 1st level, B is in the 3rd level. this number won't be a label on the tree. You have to find sum of labels. The sum of labels of paths including both B and F, yes. Remember that for intersection, we change it to AND. So let's see what we have here. So I'm looking for, that was supposed to be B. Okay, I'm looking for all paths which includes both B and F. So F is here, and then there's B up there. So I will put triangle for these ones. And there's also another one here. And you see, if I go down, there's no F there, so I won't find any other. So there are only two paths which include both F and B. So these are basically, I have to sum the numbers on those ones, in this case triangles, and that will give me what, 10 and 15. This is 25. Nice. How about union? Well, A union B, I need to find all the paths which include either A or B. This is important again. When it comes to the union, you do OR. Okay? So these ones, I will highlight them. So here, this one definitely has B. This path, and when I say this, I mean the path here going down to the root has A, so it needs to be included, though it doesn't have B, but we are looking for A or B. So this one includes B, so let me just do all the B's. But there is also one here, this one here, which doesn't include B, but it has, oh, not that one, sorry, that's not good. That has neither A nor B. But this one down there has A. So I have 1, 2, 3, 4, 5, and 6 of these guys. So I have to find the sums of all the paths in the highlighted letter or label. This will be what? This is 10, 10, 15, and then we have 8 there, and then we have 44. That will give me 35, and then 43, that's, no, it is a little bit, okay, 20, 35, 43, and then there is a 44 here. This is 87. Is there anything yet? My number is a little bit off here. I don't know why, because I have the complement. This is 61. This must be 60, 89. 10, 10. Oh, I'm missing a 2 here. This 2, I missed it. Sorry. This must be 2 plus 2 plus 44, and that will give me 89. So that is the number I found. Okay, the last one is nice. So here I have one intersection and one union. So we are basically looking for paths which includes A and at least one of F or B. So OR comes for the union, intersection comes there. So here, what are these ones? So let me first write this one, N of A intersect F union B includes sums of labels of path. It must include A and at least one of F or B. So let's see. I will use star them this time. So I will star them. So A, it must have A and B here. So I am using this star. This one has A, it has F and A, so that is also included. You see F is here, A is there, so it must be included there. Down here, it doesn't include A, so it won't be, we should not consider that. Here it is, this one includes A. It doesn't include F, but it includes B here. And well, that's it. There are only 3 of them, and we can go ahead and write that. So that will be sums of stars, which in this case will be equal to 10, 10, and there's an 8 there, so this is 28. It must include A and at least one of these guys. Okay. So that was an example which covering the rules and things. So always when you try to extract information from the tree, you have to consider paths, which paths, depending on the intersection union, you see which paths are your favorite passes there, or proper passes to pick up, and then you find the labels of these paths and add them. That will give you the number.